Joining us today from Amphenol Communication Solutions Power Solutions is Junior Product Line Manager David Beal. David is a dedicated marketing professional with over 5 years experience across diverse product channels. David brings a results-oriented and analytical approach to deliver impactful outcomes. Thank you for joining us today, David.
Thank you, Greta, and thank you for the introduction. All right, we'll jump right into it. Today's topic of discussion is power solutions, specifically for data center markets. I'll talk primarily about our BarKlip interconnects. I'll touch on some of the other product offerings that we have for the data center market. Just know that the Power Solutions business unit here at Amphenol, we have a wide range of a product portfolio that has, micro interconnects that produce 10 to 20 amps, all the way up to BarKlip connectors that support 1,000 amps at, 12 volt, 48 volt, 400 volt. So we have a wide range of products, but again, we're kind of going to narrow the focus today and talk primarily about data center solutions. So a little bit of background about the Power Solutions business unit. We have a global manufacturing footprint, and all of our manufacturing facilities are end-to-end manufacturing plants. So we do all of the stamping, the plastic molding, even the cable assembly, all in-house. So we do provide a true end-to-end solution for all of our interconnects. Right now we have manufacturing in India, and we also have 2 sites in China. Right now we're also ramping up our Mexicali, Mexico site. So this is an exciting new plant for us to support our North American data center customers. So we're just starting production in Mexico now, getting some first article samples out in Q1, and then we'll slowly begin to ramp up that manufacturing site as well. And another added bonus that we have is that all of our manufacturing sites have UL certified test labs, and they also have ISO certifications. So again, we kind of have a full range of safety and certifications at all of our different manufacturing sites. All right, so jumping into some of our solutions and how they fit into the market. If you're familiar with the data center market, you probably have heard of OCP before. OCP stands for Open Compute Project, and it's a collective of different end users that wanted to standardize and kind of formally create some specifications for data center rack and power specifically. So it was started by Meta a few years back, and many other data center customers have kind of jumped on board and contributed to the different specifications. If you check out the OCP landing page, you'll see lots of different big players in the AI market, in the data center market. Some of the different subcommittees that we're interested in for power include, the rack power specifically, the power shelf, power supplies, battery backups, right? There's kind of some different subcommittees that we like to focus on. The goal kind of for our Power Solutions team is to get our connectors listed on the bill of materials and approved, so that customers, when they pull up these different specifications, they see that Amphenol is an approved supplier of products for OCP. So next I'll jump into kind of the rack architectures. Again, in the past, it was kind of all over the place. Customers would come in and they would say, hey, I have this rack at this power output at 12 volt, at 48 volt. So the OCP community has kind of standardized everything, right? And made everything uniform and more standard. So in the past, on the left side of the screen, you see what was referred to as the ORV2 12 volt layout. This had the bus bar design was a load and return on either side with an insulator in between. We had a BarKlip solution, right, that was used for the power shelf. It was a BarKlip 200. And then the market kind of transitioned to a 48 volt rack layout, which you'll see on the right side of the screen. And this is called ORV3. So there's again, a power and return 48 volt laminated bus bar design. And then we designed our BarKlip solutions to accommodate the newly designed bus bar. And now it's a separate payload shelf for power. There's a power supply shelf. There's a battery backup shelf as well. So a little bit of a different spin on the layout, a little bit more flexible of a design. Everything is kind of cable distributed for the power instead of lugs and screws. So just a little bit more modern design on the right side. And then I like to show this. I'm more of a visual learner, so it kind of shows the flow of power into a rack in a data center. So if you start in the upper left-hand corner here, this is an OCP, right, an open rack power shelf. The blue connector that you see coming out the top of the rack, that's what we refer to as an AC whip cable. So the AC whip cable actually brings power from the overhead power in the data center facility and channels it along the side of the rack and then brings that power into what we call the power shelf. So the AC power comes into the power shelf. That power gets converted from AC to DC, and then through one of our BarKlip connectors, that DC power gets put back onto the bus bar. And then that bus bar distributes that DC power up and down the spine of the rack, and then that power can get distributed to other battery backups, IT gear shelves, servers, whatever else is loaded into the rack. And just to be clear, the only two portions of the layout that you see that we produce are the AC whip cables and then the BarKlip cables. The actual physical bus bar component is produced by one of our sister divisions. All right, so we talked about, and I just showed an example of a power shelf for a data center rack. So when we're talking about a power shelf roadmap, this is essentially what we've designed over the past few years, right? So customers, they typically design like a 10 or 15 kilowatt power shelf in the past, and we supported this with our BarKlip 500, BarKlip 600. But now, as customers' applications become more and more power hungry, right? You see the power shelf is consuming more power, and we continue to move up into the right on the chart. So recently, we've developed a BarKlip 1000, right? So BarKlip 1000 supports 1000 amps of power plus 1000 amps of return. And because the power consumption has become so large, we can no longer terminate cables to the BarKlip contacts. Now a lot of customers are going to what's called a flexible bus bar. So you can see on our BK1000, right, the positive and negative flexible bus bars that are terminated to our BarKlip contacts. And then they will actually just lug the end of that flexible bus bar internal to the power shelf to another bus bar or a PCB. So again, we continue to invest and develop higher power BarKlip assemblies, and we envision the next steps being a BarKlip 1200 and then possibly a BK 1500, and the power is just going to continue to increase as AI and servers just demand more power in this market. And next, I want to talk about the IT gear BarKlip roadmap. And I like to make a distinction between what we have shown up to this point, which is the power shelf, which is the box that specifically converts AC to DC, and then distributes that power back to the bus bar. IT gear is a very general term for all of the other shelves that are loaded into a rack. So IT gear, typically in modern times, it's referring to like a GPU box or an AI box. But it can also mean, just a standard server, a storage box, a networking switch, right? Anything that's being used for processing power or computing power. So you can see for these individual boxes in the rack, the power requirements are much lower. So in the past, on a 12-volt layout, right, we designed BarKlip 200, BarKlip 300, BarKlip 350. And then that kind of, after that, the 12-volt layouts died and everything switched over to 48 volt, we had to kind of, reassess the market. And the nice thing about switching to 48 volt is that because of the higher voltages, we could get away with the lower current rating and still achieve a higher total power output. So the most common BarKlip connector that you see today on an ORV3 layout would be this BarKlip 150. But then we've also recently developed a BarKlip 220 and a BarKlip 350. Again, we'll continue to invest and develop this line of products as well, because the individual AI boxes and the server boxes, again, they're getting more power hungry. So BK350 is our highest power output connector today. But again, we're going to continue to see this chart move up and to the right. And then lastly, I like to talk about our Nano roadmap. So again, these connectors are considered IT gear, right, for server and storage boxes. But the cool thing about the Nano is that you'll notice there's no mounting flange. There's no ears where you can screw down to hold the connector in the panel. This is just a more narrow housing, and there's actually a little retention feature in the bottom of the housing that the customer can design a latching mechanism to have this fit right into the panel of their application. So again, the customers like this because it saves space in the front of the storage box or the server box. And it's a toolless design, meaning you don't need to screw anything down or slide anything into place. You just kind of mount it in your panel, and then the customer will design the latching mechanism themselves to allow this connector to be seated in the panel and then still allow for a little bit of float. Again, we've developed additional lines for the Nano connectors. You see we have the 220, the 350, and even the 450. So this design has become very popular in modern AI applications. And then to kind of wrap up, what's new in BarKlip Power. Everything that you see on these slides is all driven by the market and specifically by, customer requests. So customers will come in, they'll say, hey, we really like your BarKlip connector. We love that it's already OCP approved. Can you modify this small feature, or can you add this small feature? And, we always try to accommodate and incorporate these changes. So some cool features we've added, starting from the left side of the page. We can now do a bottom cable exit, meaning simply that the cables just exit out of the bottom of the housing to kind of deliver power straight down below the panel cutout to a PDB or whatever is getting terminated on the other end. I mentioned earlier about the size of wires being constrained. So now we've invested heavily in the flexible bus bar terminations that allows us to achieve higher current ratings without having to terminate 6, 8, 10 limitless numbers of cables. Instead, you can just terminate to a flexible bus bar and then just lug that down inside your system. Another cool feature we added, a customer had a request for a thermal sensor on our BarKlip 700. So the thermal sensor is right at the contact point between the cable and the BarKlip contact. Right where that connection point is made is usually one of the hottest points in the BarKlip assembly. So the connector actually features a little thermal sensor that ties directly into the motherboard, and it kind of monitors the thermal properties of that connection point, and it ties into the intelligence of the system, and will let the operator know if that contact point gets too hot. And then lastly, you can see the BarKlip 1000 on the far right side of the page. We kind of have a couple of different unique ways of terminating the contacts. The bottom image shows two BarKlip 1000s stacked on top of each other, and then the positive and the negative are separated. So you have positive on the top and then negative on the bottom to achieve up to 2000 amps. So again, this was just kind of a custom design, just stacking two BarKlips on top of each other for a power shelf application that required even more power. And then next, I'm going to transition to a couple of the other products that are commonly found in the data center market. So imagine, if you will, everything that we've kind of shown so far is one end of the cable assembly. So the BarKlip connector is pulling the power off of the bus bar down the spine of the rack. And then some of the products I'll show now are what's on the other end of that BarKlip assembly. So these connectors are used to bring power inside the server box down to a PDB or a motherboard, wherever it's being terminated inside the box, so to speak. So first we have our pin and socket solution, which is CoolPower HD. You can see from the current rating table on the right side here, the pin diameters that we have tooled, and then the corresponding current rating for each pin diameter. We have a pretty wide range of current ratings covered. And then we have two different layouts. The top row you'll see is like a right angle termination, and it has a squeeze to release mechanism that you can engage with your finger to kind of unmate and mate together these connectors. And then the bottom row of connectors is what we call our vertical or straight exit, meaning that the cables just exit right out of the top of the housing. And these have a little circular pull latch that you can just insert your finger and then pull those connectors or pull the tab to unmate the connectors. And again, I just like to show this slide. It's a very good visual representation of what we've talked about so far. Oops. So the IT Gear BarKlip connector, right, that we were talking about before, this is typically how it's mounted in a panel. So you can kind of see like the sheet metal cut out, and then this connector gets mounted in there and then either screwed down or latched down, some way to secure it into the panel. And then the contacts are terminated to a cable, and then those cables would be terminated on the other end to something like a CoolPower HD, which in this example, this is a right angle CoolPower HD that's bringing that power directly down through pins and then terminated to the PDB. So that's how you bring power in from the bus bar to the PDB in a server box. Or if you need a jumper cable, maybe to jump power from a PDB to a motherboard, you could just use a very simple, 2-pin connector that's shown here through the middle of the slide. And that would kind of just bridge the power between two of the boards inside one of the server boxes. So a couple of different flavors just to show you, what customers have done in the past. And then another option, if the customer prefers like a bladed solution, if you're familiar with Power Solutions and our history, I'm sure you've heard the name Power Blade before. So this is our primary bladed connector series. Our latest offering is Power Blade Ultra HD Plus. Again, for each individual blade of this connector, it's up to 100 amps of current per blade or per contact. And this is something, again, that you would see on the other end of a BarKlip cable assembly. And then you could just terminate this as a right angle or vertical connection right down to a PCB inside the box. And so this is our latest Power Blade offering. And then last but not least, I wanted to quickly touch on the AC whip products that I mentioned at the beginning. So again, this this blue connector that you see in the top of the rack here, that is a plug that plugs into the overhead power in the data center facility. And then this cabling gets channeled down the side of the rack and plugged into the power shelf, which we talked about earlier. So when it comes to AC whip offerings, there's many different configurations, there's many different layouts, different UL certifications, depending on what safety requirements your customer needs, and also what UL listings they need to follow. Um, and it also depends on what region of the world you're operating in. So some customers will use a NEMA plug or an IEC plug, but just know that we have a wide portfolio of AC whip cable offerings that pretty much covers anything that a customer would need. And then next, I like to show this handy chart here. There's lots of different flavors and lots of different configurations for AC whip cables. You know, China has a different standard than Europe, who has a different standard than North America. So this is kind of a handy guide to show your customers to say, hey, we have all these different configurations. We follow different UL and IEC guidelines for the certification. You can kind of pick and choose what different cable terminations you want to use specifically for your data center. And then lastly, I like to show the power roadmap for AC whip cables. So again, we started off with like a 20 amp pin AC whip connector. Then we designed the 30 amp, which was targeted towards like a 15 kilowatt power shelf system. Recently, we've developed and tooled a 60 amp solution, and then kind of the next logical steps for AC whip would be a 100 amp contact solution, which is targeting again that 50 to 55 kilowatt power shelf application. And then again, as always, the chart keeps moving up and to the right as everything becomes more power hungry. We are developing and concepting now, 125 amp to 200 amp AC whip solutions that will be used in the next generation of data centers. So that is our AC whip power shelf roadmap overview. And then that concludes the presentation.
Awesome. Thank you, David. That was great. And we will now open our Q&A session if you have any questions at this time. And David, I do have a couple questions for you. What is the timing for availability for products to be
Sure.
manufactured in our Mexicali plant?
Sure, great question. So we have successfully welded some of our first articles of BarKlip cables in Mexicali. So everything is on track and being approved at the end customer level right now. So we'll support some smaller quantities in Q1, but then we plan to ramp up pretty quickly later this year, and we'll be able to support some higher volumes by the end of 2025.
Thank you, David. And are you willing to further customize your BarKlip product line?
Yes, of course. Yeah, we're always, looking for customer feedback and, internal feedback from our Amphenol team. I showed the one slide about the added features and, the new designs that we're working on. So, you know, OCP is kind of the standard in the market, but then anything outside of that is, fully open to be customized, and, we're always welcoming new suggestions on how to modify our products.
That's really great. Thank you, David. And what is the timing factor when designing new BarKlip cables? And what constraints do you foresee in future applications?
Sure. So as I mentioned at the beginning of the presentation, the number of wires required to carry 1,000 amps in a data center application it's becoming nearly impossible to weld those holes to the BarKlip contacts. So now it's become much more popular to terminate the BarKlip contacts to a flexible bar. And then, as different cooling technologies become available, like liquid cooled bus bars, and, more airflow is being distributed in the data centers, it's able to increase the performance. So we're looking to kind of leverage these new cooling technologies to increase our connectors' performance and also using the flexible bus bar terminations to increase our performance as well.
Great. Thank you, David. And that is all that we have for you today. Thank you for joining us. We hope that you enjoyed today's presentation with David Beal from our Power Solutions Business Unit. Have a great day.